Hi everyone, today I am going to discuss about floor planning. Floor planning is the process of placing blocks or macros on die or within other blocks and defining routing areas between the blocks or macros. Floor planning includes macro or block placement, pin placement, power planning and power grid design. The decision taken for macro, block placement, IO pad placement and power planning directly or indirectly impact the overall implementation cycle. Lots of iteration happen to get an optimum floor plan. A good floor planning should make the design routable, improve the performance and minimize the chip area. Now, what are the inputs taken for floor planning stage? The inputs for the floor planning stage are synthesized netlist, timing constraints, power constraints, area constraints, and physical information, IO constraints, and floor planning controlling parameters such as aspect ratio, height, width, utilization, row to core ratio. We can optionally provide macro placement and IO placement information to the floor planning stage. The designer takes care of the design parameters such as power, area, timing, and performance during floor planning. These estimations are repeatedly reviewed based on the feedback of implementation team, IP owners, and article designers. The outcome of floor planning is proper arrangement of macros or blocks, power grid pin placement, and partition blocks that can be implemented in parallel. The first step in the floor planning is estimating die size or core area. For estimating die size or core area, we use floor planning controlling parameters as inputs to the floor planning stage. First, we have to know what are these floor planning controlling parameters. First one is aspect ratio. Aspect ratio is the ratio between vertical routing resources to horizontal routing resources. If you specify a ratio of 1, the height and width are the same and therefore the core area is a square in shape. If you specify a ratio of 3, the height is 3 times the width. The next is core utilization. Core utilization indicates the amount of core area used for cell placement. The number is calculated as ratio of the total cell area to the core area. A core utilization of 0.8 means that 80% of the core area is used for cell placement and 20% area is available for routing. The next is row to core ratio. Row to core ratio is the amount of channel space to provide for routing between the cell rows. The smaller the number, the more space is left for routing. A value of 1 leaves no routing channel space between the cell rows. Floor planning installation. In the floor planning installation stage, we set the parameters, floor planning controlling parameters as inputs to the floor plan. Floor planning installation has 3 steps. Set size parameters. Setting size parameters are done in 2 ways. One way is set die or macro size, means by giving height and width of the macro or die size directly, we can set the size of the die or macro. The other way of deciding this, setting the size parameter is by giving aspect ratio and cell row utilization. The second step in floor planning initialization is set parameters for row height, orientation and separation. The row height is equal to the standard cell height. We set the height of the row and orientation and separation in this step. The third step in the floor planning initialization is set IO core clearances. IO core clearance is nothing but the space from the core boundary to the design boundary. That means core boundary. which is acted by IOs or IO pins. The next step in floor planning is macro placement. Macro placement is done manually based on the connectivity with other macros and also with IO pads. Flylines are used for placing macros manually. Flylines are virtual connections between macros and also macros to IO pads. This helps the designer to get an idea about the logical connections between macros and pads. Flylines acts as guidelines to the designer to reduce the routing resources to be used. Based on the flylines, the connections between the macros and IO pads, flylines are divided into three types. One is macro to macro flylines, macro to IO flylines, pin to pin IO flylines. Macro to macro flylines are used to get an idea that which macro should place closer to each other, and macro to IO flylines give an idea that which macro has to place nearer to the IOs, that is chip boundary. And pin to pin flylines are used to orientation of the macros. Okay, we will discuss more about floor planning in next part. Thank you.